Now we want to take a minute to talk about pointers to structures. Well, we know that a pointer is just a variable that's big enough to hold an address, and it will hold the address of the first element of a structure. That's all there is to it. So we can have pointers to structures. But pointers are an easier way to manipulate the structure members because we can do it by reference and not by value. When we call functions and pass pointers to structures in and out of the functions, the receiving functions can work on the original data, and we don't have to move copies of data back and forth like we saw before, which takes up a lot of stack and memory and just a lot of time. The entire structure is not then passed by value. Only the address of the first member is passed. Pointers can be manipulated across the members of an array, just like we saw pointers to arrays previously. When you could increment a pointer, it would go to the next element of the array. Well, if you increment a pointer that is pointing to an array of structures, it will go to the next structure in the array. Rather than just skipping forward a few bytes of an integer, if a structure is 50 or 60 bytes itself, when you increment a pointer to that kind of structure, the compiler knows what that pointer points to, and it increments at the appropriate number of bytes through memory. Here's just a little bit of code to illustrate some of this. Here we have our structure date, and we have our month, day, and year in it, just like before. This is just a declaration. We're not defining any actual variables in here, just our little structured declaration to give us date. Here's our add decade function again. This one does not return anything, doesn't have to, because it takes in a structure pointer. Now, you know what? This is a typo right here. This is wrong, and I'm going to fix this so that it's correct in our code, because right there, and this is a common mistake, I gave the struct target, but I have to give the tag struct date target. There we go. Now that's correct. So we have our add decade, and we're going to send in a pointer. Notice the asterisk. It's a pointer to a date structure. Remember how to read that? You start at the word target. We come over to the right. There's nothing over here to deal with. So we come back around. This is going to be a pointer to a date structure. All right, that's how you read that. And you go counterclockwise, the way we looked at earlier in an earlier video. So we see that target has to be a pointer to a date structure, and that's what's going to get passed into add decade. Now down here inside add decade, what I'm doing, I have a structure date called myDate, and then I create a date pointer, asterisk, right there, creates a date pointer to a structure date, and I set it equal to the address of myDate. This structure right here that's been created. So this set aside 3 integers of storage as an automatic with month, day, and year. This address of myDate is the address of the first member of month. So where it's located, and then 4 bytes away, date will sit there. 4 bytes away, year will be next to that. Something you need to be aware of is the way that your compiler will organize data in here. When you have a structure like this with the month, day, and year, these ints will be right next to each other. And the alignment and the byte boundaries are what's important. If you come along and you slip a character into here that's only 1 byte, your compiler may realign things and have a character in here and then a blank of nothing and align the next integer on an even byte boundary. It's important to put all your characters together, and then sometimes, depending on the compiler again, these are things you'll get into as you get more advanced in C, you may need to put a filler byte in to reestablish your byte boundaries, or your compiler may do it on its own. But it is something to be aware of when you're dealing with structures, and especially dealing with structures that are going to manipulate a lot of data, or you're going to be scrolling through that data quite a bit in memory. The alignment can be an issue. So be aware of that, and that's something to take a look at in a more advanced C topic. So now down here we have set the address of myDate into date pointer, and now we can say that myDate, which is this original variable, .month equals 7, just for a value. So that's our normal member access method with a dot. Now here's how you use the pointer. Remember, the date pointer is pointing to myDate. Over here, we can say that date pointer .day equals 20. Now, because of the way the dot operand and the pointer asterisk work, we need to use parens around this to bind this properly so that we actually go to the contents of the date pointer .day, and the contents of the date pointer is the address of my date, and then we get the day member and we set it equal to 20. So they use those parens. Well, that just gets really messy and it's hard to remember, and we're certainly going to mess it up. So what we do is use this new operator. This is a dash and a greater than. And these two things are exactly the same. Date pointer operator day equals 20. So this is an indirection that is done from a pointer to a structure, and this is a member reference. This is how we use the pointer and get to a member of an item within the structure that's pointed to by the date pointer. So date pointer, that's the new operand, day equals 20. Now down here we're going to go ahead and finish off what we were supposed to do with add decade, and we say that the target, and there's that new construct, that new operator, target year plus equals 10, that adds our decade to target, and we pass it back. It's already taken effect. The 10 years has been added onto that. We don't have to return anything, we just leave. And since this is a void, we won't get any errors in carrying the information back because we changed the original. We didn't have to mess with the by value. We pass this by reference by using a pointer to a structure, which is what I want you to see. Pointers to structures, manipulated just like any other pointer. We can add integers to them, subtract it from them, and that will move date pointers throughout memory across an array. All the same items that we covered before in arrays and pointers, it all still holds true for pointers to structures.